Welcome back to the Know Your Adversary podcast. I'm Jared Atkinson.
I'm Justin Kohler.
And we're joined today by our colleague Andy Robbins and by Bjorn Aannestad. Andy, would you go ahead and introduce yourself?
Yeah. Hello. My name is Andy Robbins. Along with Will Schroeder and Rohan Berserker, I'm one of the co-creators of Bloodhound. And now I'm principal product architect at SpecterOps.
And then Bjorn, if you could introduce yourself as well. You're kind of our guest of honor today.
Yeah, thanks for having me on, you guys. My name is Bjorn Aannestad. I am the Director of Product Management for Ping Identity, specifically the PingOne multi-tenant identity as a service platform.
Okay, and then Justin, I think SpecterOps got an engagement with Ping Identity to do some attack path research. Do you want to kind of talk about the background behind that?
Yeah, so just over a year ago, we got engaged together to do a potential tech partnership. And as we worked trying to through the details, we wanted to dig into the PingOne platform and understand kind of the scenarios that we see play out in other IDPs. So where could users potentially misconfigure and put themselves in a bad situation, or potentially where things have been set to where a regular user could elevate their privilege in an unforeseen way. So it was really cool. I mean, first of all, we got to meet Bjorn and work with him and the PingOne team. And also we got access to a free tenant that allowed us to do the research, kind of really quickly and be able to get to like direct access to the information.
And that's something I want to double click on is the access to the free tenant is just fantastic. So SpecterOps is a small organization. We're trying to create these attack graphs for tons of different platforms to help our customers kind of understand what their attack, it's not really attack surface, but the underbelly of their attack surface really looks like. And one of the difficulties that we have is because we're a small organization, we're also kind of known for red teaming. It becomes very difficult for us to actually get access to tenants for these different platforms and therefore do kind of like that security research to make these organizations more secure. And like that, hats off to Ping for kind of facilitating that and making that available to us because that really helped to kind of supercharge our ability to do that research. I don't know, Andy, if you want to comment on that as well.
Yeah, I actually have a thought about that. So we have a lot of positive things to say about this experience with working with the Ping Identity Corporation. And one thing I was thinking when Jared was talking about, in order for us to help our customers and our users in the open source community understand attack paths in different systems, it turns out we have to understand those systems first. And you might think, you can start to read the documentation. My experience is that documentation is usually wrong, out of date, inaccurate, frustrating to read. But as a matter of fact, one of the things I shared with the Ping Identity folks is that the documentation is excellent. It's concise, it's clear, it's accurate, it's very easy to navigate. It's a great example of what a platform documentation should look like. And that's at least coming from a security researcher's perspective. Operationally, I'm sure it's excellent as well.
It's very nice of you to say so, Andy. Thanks for the compliments. We'll pass those on to the team. From my point of view, we're very interested in engaging with you guys. When the partner group came to me and said, hey, we've got this company called SpecterOps and this is what they do. My reaction was, wow, let's take advantage of that. And there are a couple of reasons for that. One, we are a security company. We're very security focused, right? That's very interesting to us. The other is that when we built the PingOne multi-tenant platform, we were fortunate enough to start with a blank slate. Now, that doesn't happen too often in the identity space. We've got a lot of startups doing clever things with biometrics and a lot of things like that. But as far as starting with a core identity provider, kind of from a blank slate and saying, how can we build more security in from the beginning was one of the fun things about this project in the early days in the platform that's now grown into the PingOne platform. And while we were going through that, I always kind of felt this nagging need for some kind of independent validation of the design choices that had been made. And when you guys popped up on the horizon, I was like, that's what we want. We want an independent validation that some of these fundamentals we've done differently in our platform versus some of the legacy platforms out there are actually paying off.
Yeah, I think maybe Andy, you could get into, so Andy's the researcher on the SpecterOps side that really dug in, along with Garrett Foster, one of our other researchers, into the configuration. And I think maybe it's important to note that, well, we're not looking for vulnerabilities like in kind of the classic sense. We are looking for ways in which the access control model is configured that might facilitate unintentional takeover of certain applications or certain identities, things of that nature. And so maybe, Andy, you could like touch on what you found as you were digging into that, and maybe kind of like highlight what Bjorn's talking about, to where there's certain design decisions that you noticed that were different from what you had seen previously in some of the other platforms that you looked at.
Yeah, definitely happy to do that. So I think probably the best way to do this is for me to start sharing my screen and show that to y'all. And then for audio only consumers of this podcast episode, I will do my best to verbalize everything that we're looking at as well. All right, cool. So what I'm going to be doing is I will be showing the PingOne administrative portal, and I'll be talking through some of the results of our testing, talking through what the abuse primitives are, and also just talking through kind of some of the differences between this platform and how attack paths emerge out of it versus maybe some other platforms and how attack paths emerge out of those, and talk about some of the differences that we noticed along the way. So we are looking at the PingOne administration portal. And if you've never seen this before, this is kind of what you would see when you first log in as an administrator of a organization. And this organization is called SpecterOps _ C5A5A. A PingOne organization is the top level object in the object hierarchy within PingOne. So you can think of an organization as being kind of equivalent to an intra-tenant, kind of, but there are differences that we will talk about there as well. Organizations contain environments, and you can see I have a list of environments here. The administrator's environment is created by default every time an organization is created in PingOne. And then I have some other environments here that we created during testing. Environment 1, 2, 3, Garrett test environment, and then one called My PingOne environment. So let's talk about digging into some of the objects that fall under the environments. Let's look at this environment here called Environment 1. Environments are where principles, groups, applications, and other objects are actually created and managed, and let's say stored, or in the hierarchy, environments contain users, groups, etc. So in the portal, we're looking at navigating within the environment, and under this drop down here under directory is where we're going to start to see most of the objects, or at least some of the objects that we're very interested in. So we have users. Users within PingOne work very similarly to how users in other platforms work. They can be authenticated with a credential. You can set up different authentication policies to control, a user has to have a certain control applied for a particular logon from a particular geographic location, let's say. So all of the great stuff that you get with like conditional access with Intra, for example, let's say, you get with PingOne users as well. Abuse primitives, as far as abuse primitives go, the one abuse primitive that we have for users is very simple. It's very easy. It's very disruptive as well, which is force resetting a user password. That's not a very attractive option for an adversary who's wanting to execute an attack path through any environment, I would say, because obviously the next time that user goes to log in, they're going to get a bad password error, and that's a detection opportunity as well for security operations to start reacting to an adversary's actions. However, it is an abuse primitive within PingOne, being able to change a user's password to some kind of adversary known value. The way that all of these abuse primitives function all has to do with PingOne RBAC, and we will talk about PingOne RBAC in more depth when we get to it. So next, let's talk about groups. Groups also work very similarly to other platforms that at least we are more familiar with, meaning Active Directory and Intra. So I mentioned PingOne RBAC. Users, they can have role assignments, and they can be given certain permissions, and they can be given certain powers, and they can be targets for adversaries. Groups in PingOne also can have roles assigned to them. And then the immediate members of those groups will have the role assignment effectively as well through the group delegation concept. So that concept exists in PingOne as well. A few differences and a note here about where attack paths emerge from and how the design of this system prevents the emergence of particular classes of abuse primitives. So we're looking at the PingOne administration portal. You can see that I have a group here called Group 1 that has roles granted to it. If I click on the group, we can see roles. We can see that it has a role assignment for a role called configuration read only. Now, one of the interesting abuse primitives that can emerge out of a situation like this is you have a group that has some kind of powerful role, let's say. And then the administrator, they want to manage who's in that group. And platforms like PingOne will introduce tools for those administrators to make that task easier, to make group management easier. One of those is what I would personally refer to as like dynamic group membership or like rules-based membership, let's say. So let's say that, Jared creates a group called Jared's admin group, and that group has all the role assignments, has all the power in the world. And then Jared says, anytime a user gets created and that user has like admin in their username, I want them to be automatically added into this group. That can be dangerous because the complexities of how the system is actually granting privileges becomes more obscured the more layers of automation you put on top of an RBAC system. So we not only have the RBAC system, but then we have group management, and then we have the user properties that might be analyzed for dynamic group membership. And so that kind of complexity is really, really dangerous for a platform, but it's also very beneficial to adversaries because that complexity makes auditing how exactly roles are being granted. It makes that very difficult to understand. It makes it hard to audit. It makes it hard to manage. And then what happens in the real world is these things just spin out of control. And all of a sudden you have groups that have members in them and no one has any idea why that user is in there. But if it ain't broke, don't fix it, don't take them out. And so these things kind of spiral out of control. So the reason I mentioned all this,
right?
What's that?
I mean, case in point, Active Directory, right?
Sure.
Like that's probably
Yeah. Complexity is probably the greatest enabler of attack paths emerging out of systems like this. And so the PingOne mechanism here is that yes, there is a way to add users to groups automatically based on some kind of property or some rule that an admin sets up. But if a group has role assignments granted to it, you can't do that anymore. So if a group has role assignments assigned to it, you have to manually add each user to that group. And personally, I think this is a fantastic design choice. I think it prevents the emergence of attack paths that could be really difficult to understand why they even emerged in the first place. Could it give a little bit of administrative burden to admins? Maybe, but I think my perspective and maybe our perspective collectively on the SpecterOps side is that this design choice is worth the preclusion of thousands, tens of thousands, millions of attack paths that would have emerged if it wasn't designed this way.
Bjorn, I think during our conversations, kind of as we were working on this project, we had talked to you all about this, and you had kind of, your team at least had kind of explained what the thought process was behind this.
Yeah, the fundamental thought process is what Andy's talking about, which is prevent methods of privilege escalation, whether accidental or intentional. So we have rules like that say, well, you can't grant yourself a role, for example. That's another rule that exists. Another fundamental design choice we made is there is no requirement in the platform that you have a root user with all the permissions. You could create one if you wanted to when you set up your tenancy, but you don't have to because our customers value the separation of duties especially when it comes to things like separating the administrator's right to configure the system apart from their right to see end user data. So just because you have the ability to set up the configuration, the policy rules, doesn't give you the right to look up somebody's home phone number. That's a clear example of separation of duties. And by default, there is no user, whether it's a service account or a root account or anything like that, that has both of those permissions, or both of those sets of permissions. So those are the kinds of things we were thinking through as we were designing the platform.
I'm just going to say that's awesome. That's really cool that from the start, you don't have this concept of like somebody who has everything. Because honestly, that's what we're going to target on the adversary side.
That's right. And it does have some effects. It means things like helping a tenant recover access they might have lost is a bit harder, but at least we can insert some humans in the loop to make sure that that's done legitimately and not maliciously.
I see this design choice as a really great safety rail against anybody kind of foot gunning themselves with the platform. It reminds me of every so often we'll see something in Bloodhound where we'll say, well, why would anybody in their right mind ever do that? Why would anybody ever give domain users generic all of the domain head object? Why would anybody ever do that? And I've always thought that that's kind of the wrong question. The right question is, why does the system allow you to do that in the first place? And it reminds me of Murphy's Law, that if we put a little product twist on it, which is if a platform allows an admin to configure something in a certain way, someone's going to do it. Enough admins are going to do that to cause problems for themselves.
Yeah, so they're going to have a business dependency on it, right?
Yeah.
Yep.
That's a very good point. Yeah. And I would like to call out one of the things that I think is remarkable about what you guys do is the fact that when you test for these pathways, right, these primitives, you do that in the context of a given deployment, a given customer's deployment. So a lot of the penetration testing and so on and tools like that everybody does as a matter of course, do that in isolation of a particular configuration. But what Bloodhound can do is it can look at the system as it's been configured and find out if somebody has taken advantage of a foot gun or not. Right?
Sure.
And I think that's special.
Just a real quick example of how I try to explain that to people, from a completely different aspect of security, is you can have a firewall, perfectly functioning firewall, but if you put an any rule in it, you're going to let everything through, right? So that's the most extreme way of seeing that problem. But yeah.
I did want to touch on something that Andy talked about earlier, which was that organization to environment hierarchy, because that's related to this idea too. The organization, as Andy said, is a tenant. That's the fundamental large-scale tenancy object in the platform. But the environments that he showed are the subtenants, and they are isolated from each other in terms of you can grant an administrator rights to one environment but not another, for example. So that's a way of segmenting below that.
I have a graphic for that I'll illustrate kind of the role scoping, and I'll kind of explain some of the behind the scenes of what Bloodhound does. Cool. Maybe it'd be good for me to kind of finish the kind of tour here of the GUI and go through some of the abuse primitives. So we just talked about groups, and let's talk about the administrator roles. Let's just touch on these briefly. So in looking at the administrator roles, and now in the PingOne portal, I'm looking at the administrator roles page, which lists out all of the built-in roles that can be assigned to certain principals. There's a lot to talk about when it comes to the admin roles within PingOne. I think maybe one of the most important aspects is that, at least as far as I know, the only endpoint that you would be able to touch in order to grant someone a role assignment, there's one endpoint, maybe two if you're doing it by a reference ID of a user, but long and short of it is there's one API essentially that is responsible for allowing admins to grant admin role assignments. And what that means is that you don't have 25 different API endpoints or 25 different applications that you have to worry about as far as, well, I could promote someone to this role through this part of the product, but I could also promote them through this other side of the product. And guess what? This one has a completely distinct RBAC mechanism, has a completely distinct permission model. But in order to understand the reality of who can grant admin roles, I have to understand all of those systems. So I see that as a great distinction as well from PingOne to other platforms. Best example I can think of is the one that I know the best, which is Intra. So I can grant admin role assignments through the Azure portal. I can do it through the MS Graph API. I can do it through the PIM API. For a couple more days, I can do it through the legacy Azure AD Graph portal or API. What that turns into is just more complexity and more kind of obscurity or fog of war, where it can be really, really difficult to understand who has the ability to do something, because there are so many different ways to accomplish that through all these different products. So the kind of point that I'm trying to make here is that a combination of the sole responsibility of the PingOne API being the only one that can manage role assignments, and some other things that get a little in the weeds, that might be a little too in the weeds, make it so that when it comes to role assignments, I don't have an abuse primitive for you about granting new role assignments, because that abuse primitive in this platform just really isn't that interesting. And the reason for that is because the roles that allow you to grant other role assignments, they can be restricted. So I can look at an example here. If we come to identity data admin, which is right here, you can see an example here where if a principal has been granted the identity data admin role assignment, because they have this role assignment, one of the permissions in here is going to be granting other role assignments. In other platforms, that could mean like, well, I can grant any role to any principal at any scope. So that could be like a built-in privilege escalation mechanism, even though it's obviously not designed to be one. In PingOne, it doesn't work that way. So in PingOne, you have a limit on which roles can be assigned based on what roles you have. So if I have identity data admin, can I grant roles? Yes, I have that permission. But guess what? There's a further restriction. I can actually only grant these two roles, which from my perspective are less powerful than the one I already have. So there's this, again, a preclusion of an abuse primitive, because when it comes to granting role assignments, you can't grant a role with more permissions than what you currently have.
That's correct. That was an intentional design choice.
Great design choice. Great design choice. So next, we're going to talk about some stuff that might be a little more obscure. So let's talk about applications first. Applications in PingOne, there are different kinds of applications. And from my perspective, these work similarly to kind of the app registrations or service principals in Intra. So you have OAuth 2 authentication policies that you can configure for these. These applications could be used to control access to third-party applications. Like I could have like a Salesforce application in here and control access to Salesforce, through this. And when it comes to application abuse primitives, there's one that I have for y'all, and it has to do with a type of PingOne application referred to as a worker app. So a worker app, which I'm going to click on one here in the portal called Worker App 1. I'll click on this, and there's a difference between how this abuse primitive in PingOne works versus how a very, very similar one in Intra works. So in PingOne, this worker app is going to be able to authenticate using its own credential. and be able to authenticate as itself. So it doesn't necessarily need to have a user authenticate and do like a OAuth flow. The application itself is a principal. It is an identity. So it has an ID, and it has a client secret that it can authenticate with. Applications in PingOne as well, they can have roles assigned to them. And so we start to get into kind of the concept of attack paths there. But the abuse primitive here is that given the right role assignment, which my user has all of them, so I can do everything I want. But given the right role assignment for a worker app, we can actually just look at the client secret. We can read the client secret, which I'm showing here on my screen here. And using that client secret and the client ID and the environment ID, we can then authenticate as this application. So the distinction I want to show here is with intra. There's a very similar abuse primitive in intra, where if I have an app registration, for example, this example intra app reg, and I come over here to certificates and secrets, I can create, again, a secret for this application that it can use to authenticate using its associated service principal. So just authenticate as itself. When I create a client secret here, the GUI will show the value of the secret. But then if I refresh the page, you'll see that we're only now able to see the first 3 letters, and the portal and the API that is serving this information will never show the full secret ever again. The difference here is that in intra, with the right role assignment, I can just create a new secret. So it doesn't really matter that I can't read the current one. I can give it a new one. So I don't reset its password. I give it an additional password, which is just as valid as the existing one. So little difference in abuse primitive there, but similar concepts. Now, let's talk about some things that are a little bit more obscure maybe. So we're back in the PingOne console. On the left, I'm going to click on integrations. And the first thing I'm going to click on is provisioning. I don't have any here. Let's go to gateways. I don't have any here. Let's go to another environment. Let's go to Garrett test environment. So let's look at the gateways that we have within the Garrett test environment. Gateways are a class of PingOne object that can store configuration information that, from my perspective, is kind of about authenticating external users or gathering principal information from some other platform, bringing it into PingOne, and being able to add users to groups, give them permissions within applications within PingOne, all that kind of stuff. From my perspective as kind of a red teamer, used to be a red teamer, kind of like the offensive security perspective, the thing I care about with gateways is that gateways, similar to PingOne applications, have their own credential material and their own identity. So they are identities that can be authenticated, and they can perform actions within the platform. The other note is that gateways can be granted role assignments. And so what you have here is, from my perspective, from the perspective of somebody who just wants to execute an attack path, is you have a principal type that can be authenticated, that can be granted permissions. And the authentication material for these objects is most likely not going to be within this platform itself, but it's going to be wherever the host is or wherever the system is that is kind of feeding information into the PingOne platform. So we may have like a radius gateway, so there could be a radius AAA TACAX Cisco system out there somewhere that's feeding information about principals into PingOne. I might be able to lift off a credential of some kind from that Cisco system, and then turn that into, you could call it like initial access into the PingOne environment. So that's my take on gateways. Bjorn, did you have anything you wanted to add regarding that?
Yeah, there's something kind of related to this that we also were thinking about, which is when we looked at existing systems, we saw a proliferation of shared administrator accounts and service accounts and things like that. So what you're pointing out about how the worker app has a role and acts much like a user is part of that. But we also didn't want to open our customers to the temptation to share administrator accounts around, shared passwords and so on. So the philosophy there was the administrators in the system are not separate from the end users. From an implementation point of view, we put them in that administrator's environment that you showed, but all the same security rules that are available, like multi-factor authentication, biometrics, are available for the administrators as well. But an important thing is that if you do have a user who needs some extra roles to become a limited scope administrator, they don't have to have two accounts. They can have their own identity as an employee, right? And still be given that identity data admin over their department, for example, without having to have two accounts to juggle and without having the temptation of, well, let me give you my login so that you can manage those users, right? So, the ability to not distinguish fundamentally administrators from end users gives us those two benefits. They get all the same features that are available for protecting end user accounts are available for administrators, and you don't have that quite the same temptation to create multiple identities for the same person.
Yeah, great. So let's talk about probably the last thing I'll talk about in the portal here. So I'm back in the PingOne portal, and I'm looking at a tab here that says provisioning. Now, I might refer to these objects more so as propagation stores as opposed to provisioning, only because some of the API documentation and some of the endpoints refer to these objects as propagation stores. Now, what are these for? These are for taking information about principals within PingOne and putting that information into another platform. So we have two different examples here from the My PingOne environment that we created for research purposes. One here is called Outbound AD. And so we are taking users from PingOne and we are putting them into Active Directory. And then we have another one here. I think, Jared, you may have actually created this one. This one is called Snowflake Rule. And this is for taking users and taking them from the PingOne platform and then automatically kind of shoveling data about those users into a Snowflake tenant. Now, earlier I was talking about gateways, how a gateway could turn, adversary access of a different platform into access into PingOne. This is now the other way around. So this is where we might be able to take adversary access in a PingOne environment, and we might be able to turn that into access into some other platform, kind of a change of venue, if you will. These objects here, they store credentials for authenticating to these other platforms. And with the right permissions, with the right RBAC permissions, a principal can read the credential material of these propagation stores, and then obviously then authenticate into that other platform. And then what permissions you have in that other platform, what you're able to do there is going to be wholly dependent on the configuration of that other platform.
One of the things that I think is worth touching on, just from we call these hybrid paths in the context of Bloodhound, where you're able to leverage access in one environment, say AD, and then gain access to another environment, right, or another platform. One of the things that's interesting about the way that these get set up is in detection and response, we often talk about kind of this client, and just in computing in general, we talk about this client-server relationship, and there's different perspectives you have, whether you're kind of operating or collecting telemetry from the client side versus collecting telemetry from the server side. There may be more detail on one side, there's more trust on another side, so on and so forth. In this case, if an attacker has control of the PingOne environment, they would be able to see potentially that there is a relationship with Snowflake. They might even be able to see what users have a relationship with Snowflake in this example, but they won't necessarily know which of those users has admin privileges or what privilege. You kind of touched on this, Andy, but they won't know what privileges they have on the far end, on the remote end of that relationship.
I was just going to congratulate you guys on that, because it's an important aspect of this, being able to see how systems interoperate and what the paths are across system boundaries. As vendors and maintainers of these systems, we generally look at our products in isolation. But you guys bring something very valuable to that, being able to look across.
Yeah, I think we talk about that quite often. The security of one system, and I think we're showing off that like you guys have done a lot of really good work. The problem comes into how could a user, even with the controls that you guys have put in place for users, potentially footgunning themselves within your platform, how are they connecting to potentially other platforms that's putting them at risk through no fault of either of those platforms? It's just the connections that you're creating and the invisible nature of that.
And the specific configurations that the user of both platforms has set up, in innocence between the two, right? This feels a very important need to evaluate the security of that.
Maybe a reason why we're so interested in the hybrid aspect is because we started with Active Directory, and in our experience, and Justin, you might have more specific statistics on this. Almost every environment we've ever explored, every user has the ability to take over the entire environment. And so that means that if there is a connection to some other platform or other environment, you have a path to get there. That may not be true in like more modern environments and things of that nature, but that was true in was true in Active Directory. And so it's kind of been something that we're very sensitive to as a result of kind of that experience.
So now I'm going to show some of what we've been able to accomplish with the research that we did into PingOne and with the Open Graph with Bloodhound in being able to model some of this stuff, some of these attack paths, and some of these configurations within Bloodhound. So the first thing I'm going to show you is pretty basic, and I'm just going to show you just a very simple hierarchy view of the SpecterOps organization. And you can see the different PingOne environments that are contained under that organization. Very, very simple. Doesn't really tell you anything that the PingOne portal itself doesn't tell you already. But things can get kind of more interesting if we say, well, I just watched a conference presentation about propagation stores in PingOne, and I want to know within my environments here, which ones actually have propagation stores. Where should I go to start looking for some triage work I might want to do? Well, we can change the query a little bit, and we can see from the top level organization down to each propagation store that the data collector was able to collect. So from that list of 5 or 6 environments, we see that there's actually only 3 of them that even contain propagation stores in the first place, and we can see a nice list right here of those. We can do the same thing for gateways. Before I move on to the gateways, though, this also, if I'm an admin, if I'm a PingOne admin and I see this view, I might look at these names and I might just do a sanity check with, do we have a Snowflake instance that we're sending data to? Do we have Slack that we're sending data to? Is this all legitimate? It could be a good way to just to do a little quick sanity check and maybe some cleanup if maybe there's something old or something that you don't really use anymore.
That's interesting. I assume you haven't gone into this, but imagine if an attacker leveraged the ability to create these propagation stores or these gateways as a means of somehow, compromising something.
Like persistence,
I don't know.
Sure. As a persistence mechanism, sure. I think a gateway is a good persistence mechanism, actually. But one more thing
imagine if you were provisioning to Active Directory and you control Active Directory, you now have a way to capture passwords of users.
Sure.
Because you could do like DC sync or something like that on your own controlled Active Directory.
Yeah. So last thing I want to say here is as an adversary, this also gives me some good indication of other platforms I might be able to pivot into if I'm able to execute an attack path to get to one of these objects. I might be able to then pivot into Snowflake, GitHub, Salesforce, some other platform, where then the security of that platform has nothing to do at all with PingOne. It's just kind of PingOne is the way I kind of got there. The opposite we could also do. So we could look for all the gateways that are stored under our organization, and we can see that because we were doing testing, there's a lot where we're kind of mucking around in the system and we're making stupid things. Like there's one here called "This gateway has custom roles, admin role." So this is obviously not real world data, but this can kind of give us as an adversary an indication of where are some ways in, or as a defender, where are some potential avenues in to my PingOne organization environments, where if somebody compromises, let's say they compromise this Ping Federate system that's running on-prem somewhere, they might be able to use that to then gain initial access into my PingOne environment, and then the impact of that would be, of course, dictated by how privileged that gateway itself actually is.
Yeah, I think this is just a good opportunity for us to talk about. Recently in the news, there was this breach for a company called SalesLoft. They had an application called Drift, and Drift was essentially like a plugin for Salesforce. And what happened in the breach was that there was a scenario where it's kind of not descriptive, but somehow an attacker got access to SalesLoft's GitHub organization. Within that GitHub organization, they found API keys for AWS somehow, and they were able to, and I guess the Drift application was being run in AWS, and they were able to derive OAuth credentials or OAuth tokens to be able to access the customer side of the Salesforce application. And I think that just really digs into the importance of understanding not just how does an attacker escalate privilege within a kind of atomic environment, but we've kind of touched on this throughout the conversation, but how do they leverage the interconnectedness? And we talk about this idea of the clean source principle, which is the idea that when you establish a security dependency, you need to make sure that the thing that you're depending on is as trustworthy as the thing that is doing the depending. There's probably a better way to say that. But but in this case, for instance, the Snowflake example, Snowflake has a security dependency on PingOne. PingOne has a security dependency, I think, because of that Ping Federate inbound provision gateway has a dependency on, I assume, an Active Directory environment. And so now there's this situation where your Snowflake environment, unbeknownst to the Snowflake administrator, might have a dependency on an Active Directory domain. And this is why all of this kind of transitive control and downstream control is super important for us to understand, because you don't exactly know where the attacker is going to gain access, but it'd be nice to understand where they could go if they did. Yeah,
the only thing I would say on that, like we've talked about administrative rights and stuff, and Bjorn, you hit on it. Like it's about the configuration, reading the configuration that the user has put in place, and certain companies will put different value on different classes of assets or identities in their systems. And that's kind of what we're trying to do with Bloodhound, right? Not just for those super admin layers. Andy mentioned tier 0. The stereotypical owners of any like application or IDP or platform. But also like the business critical stuff. So Snowflake might hold a ton of data that we want to make sure that we like zone off and understand the access to, or a trading platform that runs in AWS that we want to understand who has access to that. So that's going to depend on the customer, and ideally we're trying to uncover that interconnected problem, the hybrid path problem, and how you could shut that down.
Yeah, because there's definitely a focus, in security research on the administrative access. But there's actually a spectrum of administrative access. On the one end, you got the root user, like we talked about. But on the other end, you have the departmental user whose responsibility is to add new employees to a department or give them rights to particular departmental applications. They are, in a sense, an administrator because they may have password reset authority that they shouldn't have, for example. So you got to watch that as well.
And understanding should or should not is highly dependent on what that kind of leads somebody to do with it, right? It could be perfectly benign again, but it's, understanding the consequences of those actions either before you do it or at least being able to audit what you have today. It was an absolute pleasure to work with the PingOne team. I know that our team was thrilled to work with you guys. The access that you provided, honestly, your work. I mean, the ability to create a ground up system. It's obviously you guys thought through that. That was well understood on our side. So awesome work to you guys. And again, thank you for letting us work with you, and thank you for joining us.
Oh, you're very welcome. Thanks for the time. I enjoyed it.